Hey guys, and welcome back to the channel. In this video we're going to be talking about hard drives, and this hard drive in particular. Now this is a Quantum IDE hard drive I pulled from an old IBM PC. It's a Quantum ProDrive ELS manufactured for IBM, and it has a 127 megabyte capacity. Now the reason why I'm doing this video, as the title already suggests, is to document an attempted repair that, spoiler alert, failed miserably. I wanted to show you how I approached this particular problem, being a novice at it when it comes to hard drive repairs. I also wanted to document the kind of mistakes that I made and how I would do things differently. And hopefully we can get some discussion going on and learn something. So I invite everybody to put in some comments on this video. I would be very interested in hearing people's opinions about it. So let's jump right in. So the story begins with this IBM value point. And no, I'm not going to be reviewing this machine. I just wanted to see if it would still run. Everything looked kind of okay from the inside. It had a non-standard power supply. It had what appears to be 4 megabytes of RAM, not a whole lot of peripherals except for the hard drive and the disk drive. But when I fired her up, I noticed the following. The hard drive started spinning, which was already good. The computer was running, but all of a sudden the hard drive stopped spinning. So that's obviously not good. So let's come a little bit closer and take another listen. So you don't hear that typical hard drive initialization sound. And after a while, the drive just spins down, even though the computer is still running. So time to get the hard drive out and see what the issue is. So we need to open her up. Now, one thing I noticed is that there was this kind of foil on the top of the hard drive here. I'm not really sure what the purpose is of this thing. It does appear to conceal a screw, but other than that, I don't know. There are also a couple of jumpers here on the PCB, and I have noticed that on some hard drives, these jumper settings matter, because if you put them in the wrong position, you can have a hard drive that starts to spin and then all of a sudden shuts down. But that's not the case here, so we need to open her up. And to open her up, you need to unscrew 6 Phillips head screws here. And I typically use my regular Phillips screwdriver here, but it doesn't work on these screws. So although this is clearly a Phillips screw head, it didn't work with my screwdriver. So luckily I had my iFixit kit at hand, and I picked up a Phillips size 2 bit. And this is the bit you need to open this hard drive. So it's very important that you have the proper tools available, because you will be needing 3 different bit sizes here to work with this hard drive. So let's open up the hard drive by unscrewing these 6 screws and cut away this kind of foil which is covering part of the hard drive. And then we can gently lift up the cover to take a look at the internals of the hard drive. And it seemed to be in pretty good shape. I didn't see any immediate damage to the platters, which was good. I have seen worse, for example, here with this drive. As soon as you open it, you could clearly see that there was platter damage. Especially here, the top platter was in really bad shape. But luckily, with our hard drive here, things were looking a lot better. So I opened her up to see how the drive would behave as I turn it on. And when you turn it on, you can slightly see the actuator arm wiggling a little bit. And it seems to be having some trouble moving that actuator arm. So the head is kind of stuck in place. And due to that, the hard drive stops spinning. Now also notice that on the top platter, we don't have any head here. So the top side of the top platter in this case is not being used. There is a head which scans the bottom side of the top platter and both sides of the second platter, but this top side is not being used. And that's good to know, because that also means that all of my making sure that the top platter doesn't appear to have any damage is of no use. But the problem here is that that actuator arm is in fact not moving. So what could be the cause of that? Now you often hear that heads can get stuck on a platter, but this is not the case here, because if you have a situation like that, the platters will not be able to move because the heads are actually pushing down on the platters, and because of that the platters can't move. But here the platters are moving, so that's not the issue. It can of course also be an issue with the PCB or the internal circuitry of the hard drive. It can also be an issue with this parking mechanism here. So there's this little plastic thing here which can hold the actuator arm in place, as I will show you later. So yeah, any number of things can go wrong. So we need to take a closer look. Now we can try and manually move the actuator arm when the hard drive isn't spinning. So we need to gently turn the platters counterclockwise, and while we're doing that, we can try and move the actuator arm. So I decided to do exactly that, but of course a big mistake on my part was not taking into account that parking brake thing there on the top, and of course the actuator arm would not move. Now notice this black thingy here which can kind of move around a bit, which goes underneath this actuator assembly, and this is actually a braking mechanism. So as I will turn on the hard drive right now, as the platters start spinning, take a look at that black plastic thingy. As the platters start generating speed and increase the airflow, the black thing kind of gets moved to the side. So let's look at that again. So notice how this will move outwards, effectively freeing up the actuator arm to move. And so as I was attempting to move the head, I needed to make sure that that parking handle wasn't in the parked position. So I gently moved the actuator arm to the outside of the platter. And at a certain point, I didn't see that the parking got enabled, and as such, the head got stuck again. And I actually used some brute force to slide the actuator arm to the edge of the platter, which is definitely something that you do not want to do. So let's see how the drive behaves with the actuator arm in a different position. And it did exactly the same thing. The actuator arm did not move at all, and all of a sudden the hard drive just stopped spinning. But the night was young and I wasn't planning on giving up anytime soon, so I decided to give the actuator arm a little nudge as it was starting, and all of a sudden I heard that very specific hard drive initialization sound. So I knew I was onto something here. Now, unfortunately, at this point, I didn't realize that I didn't have the IDE cable connected to this hard drive. So I spent a couple of minutes trying to figure out why this hard drive wasn't being recognized by the PC. And obviously that's because there was no IDE cable installed. So yeah, that's really stupid. Obviously, when you're really in the middle of things, you kind of forget these kind of obvious things. But I got the hard drive in a situation right now where the head was able to move. I could hear the hard drive initializing. I also noticed that the hard drive was making a funny sound when the actuator arm was at a certain position on the platter, so I was a little bit worried about that. But now another stupid mistake that I made. After all my hard work, I put everything back together, I hooked it up to the PC, attached the IDE cable, and the thing was able to boot. So the computer recognized the hard drive, it booted into PC-DOS, I was able to run checkdisk, everything was fine. But I didn't record any video at that point. I did take a couple of photos, but the fact that I didn't record any video is just so stupid on my part, a real shame. But not to worry, the next day, after a good night's sleep, I did decide to record some footage. But then this happened. Yep, that didn't sound good at all. So let's take another listen. So yeah, there's definitely movement, but yeah, it doesn't sound good at all. So back to the drawing board and let's open up our hard drive once more. Now I know normally these things need to be opened in a clean room and there is definitely a chance that dust gets into this thing, but I mean, it's my hard drive. I'll do what I want with it. If I cared about the data which was on there, I probably could have gotten it off the day before, but I don't really care about the data, so this kind of became a learning experiment for me. I mean, the hard drive was completely dead to begin with. I was happy to see it running for at least a day, and at this point I much rather have a hard drive which kind of works than a hard drive that doesn't work at all. I'm not going to be storing any mission critical data on this thing anyway. So yeah, I just wanted to open her up to see if I could see some physical damage here, and I also wanted to see how the hard drive would look like as I turn it on and have it hooked up to a PC. Now obviously at this point I didn't even realize that the top side of the platter wasn't being used, as there was no head, so a visual inspection of this top side platter is completely useless. So I did want to see if I could kind of move the head. Again, I didn't realize the parking brake was on, but at this point the actuator arm could in fact move, as I will show you now when I power up the drive. So platters are spinning, the head is moving a little bit, it's doing its initialization, which is good, but then all of a sudden things go horribly wrong. So you can see the actuator head slamming inwards 2 times, so it's definitely hitting something over there. And after a while the hard drive simply spins down. So we went from a hard drive with an actuator arm that wouldn't move at all, to a semi-working hard drive, being able to boot into DOS, into a hard drive that just slams the actuator arm inwards. And on top of that, at that exact time, this coil wire got separated from one of the heads, so that's also a major issue. And this is something that I totally didn't see at first. I mean, as you're working on this thing, these things go a little bit unnoticed, and it was actually me looking back at this footage that all of a sudden noticed it. And here you can see that the heads are on the outside of the platter and everything seems to be fine, but as it kind of hit the inside of the platter a couple of times, all of a sudden I noticed that this wire coil came loose, and you can see it here in this footage. So as we zoom in, you can clearly see that this coil wire is kind of hanging loose, and it's probably scratching the underside of the platter right now. Whereas here, I mean, 1 minute before, things were still normal. So my guess is, as the actuator arm was kind of slamming towards the inside of the platter, this thing came disconnected from the head, and from this point it's pretty much game over. I mean, looking at it like this, magnified to a large extent, you could probably say that you could put some super glue on it and it would work just fine, but this is really tiny. It's virtually impossible to get tools in, so yeah, that was a real bummer. And in retrospect, I didn't immediately notice that there was an issue, because it's very difficult to see. You really need to look in between the platters to see that there's something kind of bangling on this head. So I just continued working on it, still thinking that I would be able to fix it. So I decided to remove the actuator bit here so that I could take a closer look on how the actuator arm is kind of moving around. So this is heavily magnetized, so it's very difficult to get this off, and you need to be really careful when pulling this off that you don't slam it against your actuator arm. And one of the things that I noticed here is that there was a lot of black goo here on this part of the actuator arm. And also on this actuator bit here, you could see this rubber bump stop, which is used to kind of prevent the actuator arm from going too far, that has completely disintegrated. And that's one of the problems that you have with these Quantum ProDrives, and that is that these kind of rubber bumper stops, they start deteriorating over time. And when that happens, your actuator arm actually gets stuck on that gooey material. So that will definitely cause the actuator arm to get stuck on there, and the hard drive will not be able to generate sufficient torque to move the actuator arm by itself. And just look at how, gooey this thing is. It cleans up pretty nicely with some isopropyl alcohol. You do need to spend some time scrubbing, but it cleans up pretty nicely. So I'm going to add some heat shrink tubing here. I'm also going to be adding some tape just to make sure that everything is held into place. So now it's time to put the actuator back, and because this is very magnetic, you need to be very careful and not slam it against the actuator arm like I did here. So that's another mistake that I did. When you reattach this thing, you need to hold the actuator arm firmly in place so that it doesn't start moving. And here you can see the coil wire which has been attached from the head again in close-up, something that I didn't notice at first. So yeah. At a certain point I did notice it, and then here you can actually see that it got separated. And I also noticed the same black residue underneath the platters here, so that was another problem that we needed to look at. Now on older Quantum hard drive, the second bumper stop is located on the actuator, but here in this case it's located underneath the platter, which makes it very difficult to repair. Because the first thing you want to do is you want to get that actuator arm off of the platters, and that is really difficult because you don't want these two heads to touch. So these heads are currently separated by the platter, but as soon as you move it off the platter, the heads will just collapse against each other. And for that, I mean, you need some pills, because I saw a YouTube video of a guy who made this tool out of this, pill foil material. So the idea is that you cut off a slice of that foil, you cut it into the correct length, and then you take something that you can stick in the middle, and then you fold it like so, and that should give you a tool that you can use to kind of slide in between the platters to make sure that the two heads that you see here, which are currently separated by the platter, that you can use this tool as you're sliding the heads off of the platter. The tool will make sure that the two heads aren't making contact. But yeah, I failed miserably at that because I could clearly see the head assembly moving as I was sliding it back onto the platter. Obviously the top head here already broke off, so at this point the hard drive was already lost. So here I'm just kind of practicing this technique. But yeah, it's very difficult. And this is what it looks like with the tool inserted between the two springs that kind of hold the two lower heads together. So if anybody here is watching who has done this type of repair, I would be very interested to know how you guys kind of remove that actuator arm from the platters without the heads making contact. I know that there are specific kits that you can buy on eBay and AliExpress which contain some 3D printed parts that act as kind of a comb that you can put between the actuator springs. But I don't know if these exist for older hard drives. So on to the next mistake. And here I was thinking that it would just be a little piece of cake. I would just remove the two platters from the hard drive. So there are 3 screws that you need to unscrew here on the top. Obviously I'm smudging all over the top platter, but that doesn't really matter because there is no head which is reading data off that platter, so no big deal. I'm just going to remove this little thing here and then just take the platter out. Now to get the bottom platter out, we need to remove this little ring here first. And then we can try to get the bottom platter out. But of course the epiphany kicked in much too late, and obviously you cannot simply remove these platters independently. I mean, these two act as a pair. When the hard drive is low level formatted at the factory, it is formatted in such a way that it expects these two platters to be perfectly aligned relative to each other, so removing any one of them independently will just ruin the drive. I guess in theory, if you would be able to low-level format this IDE drive with the two platters placed in some kind of random way, the low-level format would probably be able to write the sectors correctly, and then these two platters would be paired. But because you cannot low-level format an IDE drive, this basically ruins the drive. But back to the issue at hand, and here we see the reason why the actuator arm was slamming against the inside of the platters. So if we take the actuator arm here, so the first bumper stop that we saw was to prevent the heads from sliding away from the platters, and this bumper stop is to prevent the heads to slam into that middle section where the platters are located. And because this rubber has deteriorated, according to me, the actuator arm was able to move too close to that middle section and it basically slammed against it. And my theory is that that was the root cause of that coil wire to get separated from the top head. So yeah. So now when you're in the middle of doing a repair like that, sometimes these little details don't immediately come to your attention, and it's only after looking at video footage that you see all of the stupid mistakes that you did and when exactly certain things went horribly wrong. Now, I just wanted to continue with this quote-unquote repair. So, cleaning up this gunk here underneath the platters can be done with some isopropyl alcohol, much like the rubber stop on the actuator part. I mean, this cleans up pretty nicely. And then I use the same technique to kind of recreate the behavior of that bumper stop, and then clean off the actuator arm, because there was a lot of gunk here on the actuator arm itself because it was slamming against that bumper stop. So I cleaned all of that off also. But yeah, again, I mean, you can clearly see the heads touching here, so these heads are probably ruined the moment that they touch. They get out of alignment and you will never be able to read data from the platters again. The fact that the platters have been totally removed also doesn't help, obviously. So yeah. And here you can see me in all of my naivete, just adding the platters back to the hard drive, carefully putting that ring back on. I think I even made the mistake of putting the top platter at the bottom here, but it doesn't matter anyway. I mean, these two platters would never be aligned properly ever again, so yeah, it doesn't really matter. Let's just drop a screw here on the platter and just carefully lift it off with my dirty fingers, all in a day's work. So yeah, this basically concludes my embarrassing repair of this Quantum ProDrive. In my defense, because the bumper stop was underneath the platters, this was going to be an impossible fix. I'm not really sure if it's even physically possible to get these platters off without misaligning them. I don't have the proper tools to do that. Even kind of removing the actuator arm is really difficult, especially if you're using these kind of homegrown tools. It's definitely worthwhile to practice a little bit with broken hard drives, I can imagine, to see if you can pull off these kind of repairs. But anyways, I mean, it was a learning experience for me. Now, obviously, when I got the drive to begin with, it wasn't working. I could probably have slammed it with a screwdriver or something, or hit it on the head or whatever, and try to fix it without opening it, but it would definitely have been a temporary fix. So I went ahead and opened it. I know that, I mean, it's a far from ideal situation, but then again, a hard drive that doesn't work is also not ideal. So yeah. So a couple of key takeaways. Know your hard drive. Every hard drive type or manufacturer has these kind of known issues. In this case, it was the rubber bumper stops that kind of start disintegrating. So it's useful to know that up front. Make sure you have the correct tools. You have lots of different screws here, so make sure you have your kit ready. When you achieve success, make sure you tape it. If you're testing a hard drive, make sure your IDE cable is connected. When removing the actuator and putting the actuator back, be very careful, because this is a very powerful set of magnets that you have here, and it will, slam against your actuator arm, and this is definitely something you want to avoid. Make sure you have the know-how and the tools to slide an actuator arm away from the platters without damaging the heads. Make sure you record a lot of footage, take a lot of pictures, because that can help you in diagnosing issues after the facts also. take into account that there is something like a parking handle or a parking brake that will hold your actuator arm in place, and don't think that you can just, remove platters and put them back in, because that's not the case. So that about wraps up this video. I hope my suffering will benefit some of you as you are attempting to perhaps fix hard drives or try out various techniques. Make sure to check the comments or leave a comment, as I am sure a lot of people smarter than me will be able to provide some useful input to this video. I hope you enjoy some of the other content that I have here. If you do, make sure to subscribe, hit the like button, give some feedback below. I'm very interested in hearing what your thoughts are, and I hope to see you guys very soon. Bye-bye.